In this video, I'm going to be showing you how to build out a Perplexity style RAG, so retrieval augmented generation app in Next.JS using Supabase and Langchain on the back end. So as you can see, the flow of how the application works is very similar to Perplexity if you've used it. So Perplexity is an app that I use all the time. It's one of my favorite implementations of an LLM style app, and I thought it'd be interesting to take an approach on how we could build something like this out. So in this video, it was the first time that I used Supabase Realtime, and it's very similar to the real-time database that was sort of popularized by Firebase. So if you've used Firebase before for like a chat application or something like that, it's going to be very familiar to you if you've used it. Now, to set all of this up, so I actually have it set up in a way where you can do all of this for free. So I have it set up on a free tier of Supabase. I have it set up on a Brave search API, which gives you a generous amount of search queries every month. I think it's 2,000 or so. And then finally, it gives you the ability to swap in the LLM that you want to use by leveraging Langchain. So if you want to use something like Olama, you definitely can use that by just swapping out the chat portion that we're going to be using on the back end for whatever model that you want. So this is set up in a way where you really can swap in different models that you want. So I'm going to be using OpenAI for simplicity's sake in this example. And if you haven't used the OpenAI API, you will be able to experiment with $5 worth of free credits to get this set up. So it does take a little bit of setup to set up your Brave account if you don't have one, your OpenAI account if you don't have one, and then finally your Supabase account if you don't have one. Now, the way that I'm going to be going through this is I have everything that we need in primarily two files here. So I have our page.js for our front end, and then I have our route for our back end. And now after this video, if you want to break this out and have the components in separate files and do whatever you want with it, feel free. I'm going to post a link to the GitHub repository, but just for the demonstration and tutorial sake, I'm going to go through the flow of the front end, then back end, and show you everything that you need to set up. So like I mentioned, you're going to have to get a few API keys. So go ahead, set up an account on OpenAI. It's very simple to find the API keys, similar to the Brave search API. Just make an account, go into settings. You'll find all the API keys very easily. And then finally, with Supabase, once you set it up, I will actually point this one out because if you haven't used it before, you might have to do a little bit of clicking around. But once you make a new project here, so this is the project that I'm using here, you can go within the project settings. And within the project settings, if you click API, you're going to need your URL, and then you're going to need your service role secret. Now this is for your environment variable, and then we're going to be putting this into the front end of our application, which is safe as our public key here. So once you have all that, you can plug all those in, you put it in a .env, and I didn't even mention, so because we're using Next, if you're not familiar, just go ahead, run npx create next app at latest. So this is set up with the Next.JS 14, which just came out. We're not going to be leveraging some of the new features like server actions and all of that in this, but it will be compatible if you go ahead and run this at the latest version of Next. So once you've gone ahead and run that command, make your .env, you can go ahead and start to scaffold out your project like I have here. So you see I have a simple structure. So we have our source app. Within our app, we have our API, and I just called it Backend. I'm just going to be using plain JavaScript for this. So it's mainly just to show you how you can sort of take an approach to make an application like this. If you want to swap it out for TypeScript, go ahead and do so. So like I said, there's going to be a GitHub. Feel free to do whatever you'd like with it. And then finally, we have everything within our page.js here. So once we have that set up, our API keys all plugged in, you can go ahead, close out this file. Now, the things that we're going to need to install are all within our package.json here. So if you go ahead and npm or You can use Bun. I've been using Bun a lot lately just to install and actually run everything instead of Node lately. And it's worked great. It's really, really quick. I'd encourage you to check Bun out if you haven't already. But these are going to be the handful of things that we're going to install. So some of them are for the front end, some of them are for the back end, and I'll go through them more in detail as we actually get to the portion where we use them within the code. So like I mentioned, I'm going to start off on the front end. I'm going to run through all of these different steps. Now, it does look like a number of different steps in both of these, but it is only several hundred lines of code across both the front end and back end. And now there's a ton of different ways you could approach this. This is the approach that I took to explore Supabase Realtime. But there's a number of different approaches you could use, like WebSockets and Socket.io, or even a Bun WebSocket server if you wanted. So the first thing that we're going to do within our page, so I'm just going to declare that we're using, this is on the client side, we're going to use strict in our case here. Then first what we're going to do, we're going to import some of the core things that we're going to use within React. Now phosphor icons, that's just going to be some of the icons within the application. So if I just go back to our application here, we see a handful of icons, just some sort of nice to haves. Then we're going to be using a React Markdown editor. So I had a comment in a recent video of someone asking, how do we use a Markdown editor in these applications? So hopefully this sort of answers that question on how you can use it. Now, it's a very simple implementation, but you can go ahead and look up the React Markdown editor and see some really good implementations of how users have configured it to make it look really nice, like ChatGPT or whatnot. Then finally, we're going to be including our Supabase here on the front end. So the first thing that we're going to do is we're going to initialize our Supabase client. And this is where we're going to be putting our key like we saw on the GUI of Supabase here. So we're going to grab this key and put it within the front end of our application. So this one is safe. This one is not. So this needs to go within your environment variable. So once we've done that, we're going to first wrap this main page component in our home component. We're going to declare a number of things here. So we're going to be using a ref to actually scroll down the page. So as the messages load, it's going to go ahead and use that ref just as a marker, sort of like an anchor to continually scroll down the page. Then we're going to set up a hook for our input and our message history. So essentially all our message history, they're going to be going right into Supabase, and then based on Supabase, that's going to be essentially how we manage the state of our application and the order of all our messages, and then we're going to map it out essentially once we get to the JSX portion. So here's a simple auto scroll to the last message that we have within our use effect. Then next in our next use effect, this is going to be what we use to handle the inserts depending on the payload type. Now there is a little bit of code in here to specify if the payload type is of type GPT, and that's to be able to handle that streaming in of that response for the GPT messages in particular. And it doesn't necessarily need to be GPT. It could be like Mistral or whatever you want to use here. But if you're using streaming responses, you just have to set up so that the last message gets added to that portion of the array. So here is going to be how we subscribe to the Supabase channel, and we're going to be listening for the insert events in our table of message history. Now this is going to be for when we initially load up the application and it sets all the history of our application. From there, we're going to have the function to actually send the message across, and then we're going to be setting the input just to clear. So you have that familiar clearing of the input, so you don't have to backspace and whatnot. So our backend, very straightforward. So, naming is hard in programming. I just call it backend. You could call it something more appropriate if you want. We're essentially just going to be sending the response of the input to the backend, and that's it. That's the one piece that's going to go back. Is the input or the follow-up questions, which is essentially going to be an input as well. So from there, we're going to render out our home component here. So I'm going to go over the message handler in just a second, but essentially what we're going to be doing to render out our components is we're going to have a hash map of all our different components. And it's going to go through and see what type of payload that it's receiving. And depending on the payload, it's going to map out the different component. And now this can be useful if you want to use a number of different rendered UI components that aren't just like streaming text or simple text. So you see I have boxes here that I rendered out for like the sources component type. I have obviously the streaming text response, but you can do a handful of things. So if you want to render out, like a map or a chart or something like that, you could very well do it with this implementation. I'll probably do a follow-up video eventually where I can show you how to do those sorts of things with some more involved type of UI components. So from there, we're going to be adding our ref below where our messages map out and then where our input component is. And both of these components, as well as all our other components, I'll go through in just a moment here. So our first component outside our main home component here that we're going to go through is the input component. And essentially what this is going to be doing is we're just going to be listening for the change. So essentially as someone's typing on the keyboard, we're going to be setting that input hook. And then if the key down is enter, it's going to send that message. And then we're also going to have the button with our arrow from the phosphor icons to send that as well. So next, we're going to have our query component. So our query component is like the simplest one. That's going to be essentially just what we send across here as our initial message. Now our sources, now you can swap these out and be a little bit more involved with some of the logic. You could also do this on the back end if you wanted, but essentially what we're doing here is we're going to truncate the text so we don't have a large piece of text and just to sort of blow out these source bars here. And then we're just going to be putting only the URL in this format with this extract site name here. So from there, again, we're going to grab a nice little icon. We're going to put the title of sources, and then we're just going to map out all those different sources with some of the normalization that we have above. So next, we have another one. So vector creation. Now this is just one that will temporarily show. So it will show as each vector gets created. And I'll go over this a little bit more on the back end. But essentially how the application is working is it's going to pass in this piece of text. Then from that, we're going to extract a good query for a search engine. Then from that, we're going to pass the search engine query to Brave. And then the Brave API is going to respond back with the top results. Once we have the top results, we're going to go ahead and essentially scrape those pages. We're going to embed all those pages. Once we've embedded those, we're going to do a similarity search on those top results. So you'll be able to swap this out for more than 4 results once you get there, and I'll sort of go through all of that once we cross that bridge. So this will just show that initial message, and then it will clear it so it doesn't sort of hang out. So next we're going to have our heading component. So this is going to be where we just render out the answer here. But if you wanted to use say other components and render out a heading separately, you could also reference that heading for another heading of a component later on. So next, this is going to be our simple implementation of the React Markdown viewer here. So for instance, if there are links within here or annotations, it will render out and you'll be able to click them. So this is similar to how a lot of applications render out Markdown. But like I said, this is a very simple implementation. All we're really passing in for the configuration are to make the links blue here. But there's some really big examples. I just wanted to keep it very clear and concise that to get a very basic Markdown editor here, that's essentially all you need. So from there, we're going to set up our follow-up component. Now within the follow-up, we're going to also have nested within it another ref to scroll down. So when I set this up without the ref to scroll down, this component did not act kindly for scrolling down. So it would sort of load the messages and stop about here. And I ran into issues, so I just nested it within this component as well, in addition to the other ones that we have. Okay, so here we're going to basically do a simple check to make sure that it is JSON. Now there's more sophisticated checks that you could to make sure that it is JSON content, but because on the back end we're asking the LLM to generate JSON, sometimes it can fail. This is sort of a safeguard so it doesn't break our UI here. So here we're going to handle the click of the follow-up message. So if someone actually goes and clicks on one of these follow-up messages, that will essentially perform the same action as setting the input and sending that message across if you actually typed out a message. So here we're going to map out and set up the follow-up component. So again, we have our icon, we have our heading. Then from there, we're going to loop through all of the different follow-up answers that we have generated from our LLM response, and then we're going to scroll down. Now finally, our message handler. So this is going to be where we actually discern which component to use depending on the type of the payload that is seen from the Supabase real-time instance. So here, we have our simple map, we have query, source, vector creation, heading, GPT, follow-up. Now those components all map to the same keys that are responded within the key of type, or I should say they're the same values of the key type within our Supabase real-time database. And then from here, this is going to be just how we determine which component to use. So if it exists within this map here, go ahead and render out that particular component and its contents, as well as passing down some functions that we might need, like send message. So that's it for our front end. So like I mentioned, not a ton of code. It's about 240 lines of code. And then our back end will be just as hopefully straightforward as this. So I'll just hop into that in just a moment here. All right, next we're going to be moving on to our backend. So if you haven't already, go ahead and make a directory of API and backend, and then just go ahead and make a route.js. So once you have that, we're just going to go through all these different comments that I've set up here. So first, what we're going to be requiring is the recursive character text splitter from Langchain. We're going to be using a handful of things from Langchain. Now you could also take this even a step further and require all of the things that we're using within OpenAI once we get to them within Langchain. But in this example, I'm going to be using both the OpenAI v4 SDK as well as Langchain. And then similar to the front end, we're going to be including Supabase here. Now, all of these different things I'm going to go through in more detail here. So the Brave search is pretty self-explanatory, but things like memory as well as the OpenAI embeddings, you'll see their function and understand it a little bit more as we get into the code of that portion. So first, we're going to be initializing both the OpenAI and Supabase clients with our environment variables that we put in at the beginning of the video in our environment variable file here. So first, we're going to be setting up a simple function that is going to send the payload to the Supabase table. So essentially what's going to be happening is, depending on the state and period at which this backend is executing, it will add different messages to our message history depending on the type and the responses from the LLM or the initial query and things like that. So that's going to be essentially our handler for adding things to the database. And then everything that goes to the front end is going to be from Supabase. So we're not setting it up in a way where we're going to be first sending it across with our post request or with a WebSocket. Now, you very well could do that, though, is something I just want to sort of put out there. Is like I mentioned earlier, you could use something like Socket.io or Bun WebSockets, send it to the front end, then log it to the database. So a couple different approaches here. So the first thing that we're going to do is we're going to rephrase the input of what we receive, and we're just going to sort of clean it up a little bit for the initial Brave query. So all I'm saying here is you are a rephraser and always respond with a rephrased version of the input that is given to a search engine API. Always be succinct and use the same words as the input. So essentially, if someone puts in something and it doesn't entirely make sense, this is going to add a little bit of sort of padding to that to hopefully pass it off to the Brave API with more relevant and like a good search engine query. So from there, we're just going to be returning the content from the GPT 3.5 Turbo response. And then from there, what we're going to be doing is we're going to be setting up our function to get all those sources. So on our front end here, we have our sources, and this is going to be where we set up and parse out the number of sources that we want, set up all our embeddings and all of that, and I'll cover it a bit more as I go through this here. So the first thing we're going to do is we're going to load up Brave. We're going to load in our API key here. Then we're going to call our rephrased input function here from the LLM. So this is going to respond with whatever GPT 3.5 Turbo thinks it should need as an adequate search engine query. And then from there, what we're going to do is we're going to go ahead and use our loader here and call the rephrased messages within our docs here. So if I go ahead and actually look up our loader here, so our loader is going to be calling the Brave search API, and then we're going to load all those docs that we're going to be getting back into an array here. So by default, I believe it's 10 results that you get back from Brave, and then from there we're going to go ahead and parse out 4 in our example. So obviously, the more that you load, the more that you sift through, the longer that it is going to take. But there are going to be some things that we do run asynchronously to speed up the process a little bit while it's embedding. So first, what we're going to do is we're just going to call our normalized data function. So I just put it within here just so it's easy to see. All that we're going to be grabbing from Brave is the title, the link, and then we're going to be excluding results if it includes brave.com. Now, the reason I put in this is, as an example, if you want to filter out certain results, I found when I asked for news, it would return results for Brave, and I was looking for other results that were sort of outside and other news organizations. But that's just an example of if you want to filter out different things, you could include that there. So then we're just going to return with the normalized links. We're going to only return 4 in this example. Then once we have that, we're going to send our sources to the front end, all normalized and clean for us just to render to the UI. So next, we're going to initialize our vector count. Now, another thing that you can do for the scanning document portion is if you want to send back a response with each scanned document, you could go ahead and add in it all within here, and you can have the UI be a little bit more responsive instead of just that one bar that comes across the screen that says scanning documents. So we're going to wrap this in a try catch. We're also going to set a timeout. Now, the reason that we have this set up is because we're going to be making fetch requests to the web page. And in this, we're just going to be doing a simple get request to the web page. We're not going to be using Puppeteer or anything like that. And now a lot of websites out there will require something like a synthetic Chromium browser to get the content. So essentially what Puppeteer would do is it would wait for the page to load, wait for the JavaScript to execute, and then you could go ahead and parse it. Now that's both more expensive computationally, and it's also an extra step. But if you do want that and you do want more results and you want it to be able to parse the internet a little bit better, I'd encourage you to look at Puppeteer. I'll cover that in a future video, but it's a little bit more involved to set that up as well. So we're going to be sending in the link. We're going to be getting the contents of the HTML. Now this promise.race is going to be how we have all these requests go out in tandem. So instead of waiting, okay, go scan this page, embed them, etc., one at a time, this is going to be how we essentially send them all out. We're going to be waiting for them, and then they'll all resolve and get that response. So instead of waiting for them one by one, we're just going to wait for them all to come back. So first we're going to check to see if there's a sufficient length of the HTML. So if there's some cannot parse this page or whatever it responds back with, if there's like a 400 message, or if there's just enable JavaScript to use this page or something, we're just going to hopefully skip over that content because it's not going to be relevant to what we're doing here. And then next, what we're going to be doing is we're going to be splitting the text of the web page into chunks. And the reason why we split it into chunks is we're going to embed each of those chunks to perform our RAG against the LLM. So what we're going to be doing is we're going to be chunking it. We're going to be embedding it into vectors. Once we have those vectors, we're going to go ahead and take the query from the user and see what's similar within the page. So essentially the query is going to go in and look through that page and respond back with the top result. So what you're also able to do, and I'll point this out in just a minute here, but you can query for more than one result. So within the similarity search, it's going to respond back with the number of top results that you specify. And then depending on the top results there, you can go ahead and pass it to the LLM, like we'll see in just a moment here. So what we're doing here, we're going to create our vector store from the split text. We're going to be passing in the link as well into our embeddings. And then what we're going to be going through is we're essentially going to be looping through this function here. So we're going to be creating these vectors as we get the length of the data that we want to parse. Now, the other thing is it is going to skip if it times out, and then it is also going to skip if the length, so it's not actually going to split those up and embed those if it's too short. Then last, we're going to just log out an error if it's skipping certain pages. So say if you're testing this out and there's a certain page and you really want it to parse it, but for whatever reason, it's not loading, it's just going to indicate that link is skipped. So if there's something that you're querying and it keeps failing, that at that point is when I would encourage you to look at Puppeteer and implement something a little bit more sophisticated to actually parse and scrape those web pages. So what we're going to be doing here, we're going to wait for all the fetch requests and the promises to be processed. Then from there, we're going to loop through the 4 that we specified. So if you want 8, you could do 8. If you want 5, you could do 5. Feel free to do what works best for you here. So obviously, the higher the number, the more times you're going to be querying that embeddings endpoint, and then the higher the context that you're going to be passing to the LLM as that payload. So essentially, the more results, the more expensive, but arguably more accurate. So once we have that, we're going to filter out all our unsuccessful results. We're going to get our top 4 results. And then from there, we're going to be sending over that payload to Supabase, and we're going to be specifying it vector creation, and that's going to be where it sends this message temporarily to the front end like we had set up on our page.js. So it's just going to, for a few seconds there, just show finished scanning sources. So once that's all done, we can trigger our LLM and get our follow-up message. So what we're going to be triggering our LLM with is our message as well as the top results here. So I'm just going to be stringifying it. You could also parse through that payload and make it just plain text. I found that stringifying it actually works pretty well because the LLMs will understand the context of each different source, sort of grouped together within that JSON structure. So next, we're going to have a simple fetch page content function, and this is going to be where we extract the text. Now, once we extract the text from the page, we're going to be using that Cheerio library that we went ahead and included, and we're just going to go ahead and clean up some of the tags that we don't want to have within our results. So like the script, style tag, head tag, you can be a bit more sophisticated here and remove some other things, but just to get hopefully mostly natural language text as in the results. So it's not like putting in JavaScript and you're asking text questions about like the JavaScript that's actually executing on the page, that sort of thing. So this is just a simple example. You could really blow out this function and make it like really more involved and get like a really good across the board implementation of how you could parse the page. So from there, we're going to write out our trigger LLM and follow-up function. And what we're going to be doing here is we're going to get the GPT results from the input. We're going to get the follow-up results, and then we're going to be sending those across. So what we're going to do is first, we're going to go within the get GPT result. Then it's going to wait for this to finish before it actually sends the payload to Supabase for the follow-up. And then this is going to be for our actual next endpoint to show that it's processing the request here. So within our get GPT results, what we're going to do is we're going to accumulate the content of the stream, and we're going to be adding that within Supabase and concatenating it as it gets streamed in. So this is just making sure that it will accumulate in order. Initially, when I tried this, if you're sending things and it's not awaiting properly and whatnot, and you're not managing that stream state effectively, it can appear out of order. So just to be mindful of why we're accumulating it here. So once we have that, we're going to create an initial row in the database for the GPT stream. So then we're going to be sending over our heading. So we'll have that just appear right when the answer is about to go ahead and iterate through. And then we're just going to start iterating through the stream that is from our GPT 3.5 turbo response. Now, one thing I'll note here, within each of these functions where I call the chat completion from OpenAI, you could swap this out for a different model. So if you don't want to use GPT, you want to use a local model like Mistral or Llama or Code Llama or whatever you want, you can swap out all these different portions here within all these individual functions. There might be some syntax and things you might have to change a little bit, but just to be mindful, if you want to swap them out, you can do that. So once we have that, we're going to see if the content exists within the message, and then we're going to accumulate the content within our string here at the top here. Then we're going to go ahead and update our row with the GPT response. So next, we're going to generate a unique stream ID. Now, this is sort of optional. You don't necessarily need this to work with the implementation, but if you want to start to scale this out and make it something where you can have different users and different threads and all of that, you can start to put in different payloads within your setup for Supabase to be able to have unique keys within everything. And the one thing that I am going to show you at the end here is I just want to pop over to Supabase and show you some of the configuration that you'll need to set up this real-time streaming within your database. So I'll just remember to show you that right at the end here. So here we're going to be generating that unique stream ID. We're going to be creating our payload to GPT. We're going to insert that into our message history database here. And then we're just going to have it return. So we're almost there. So next we're going to update the row with the GPT response. So we're going to be deleting that initial row, and then we're going to be inserting the new message here. So there's a number of different ways that you could do this. Being the first time that I use the Supabase Realtime database, this was the approach that I sort of explored. And the one thing that I will note is I tested this with WebSockets. And if you want streaming responses that are faster, you will get faster responses if you send the results directly back from the LLM to the front end and then put it within the database. But the thing with this is if you send the query, you can go ahead, send the query, and then it will be running within the backend as you're parsing. So, and the other cool thing with this is if you have this loaded up on multiple devices, that response will come back in real time across the board. So it's sort of neat. It's generally used for a chat application, but just sort of an aside. All right, so next we're going to be setting up our function for generating the follow-up. Now this is going to be where we try and rely a little bit on the OpenAI LLM to generate a nice payload for us. So with this one, I actually chose to use GPT-4, and I'm asking it specifically to respond back in a particular format. So GPT-4, it's not a huge amount of text generally that you're going to be sending to this follow-up, and it's not a huge amount of text for the follow-up questions that you're going to be getting back. So it's not a huge cost to use the GPT-4 for this particular function. So once we have that all set up, we're just going to define our post function for our API, and then we're going to send, once we get our message parsed, we're going to send that initial query message right back to Supabase, so it saves within state, and then once it's within Supabase, it's going to paint to the front end. And then finally, this is going to be the function that actually starts the whole process every time. So it's going to start the search engine, return the sources, etc., etc. So just like I mentioned, so once you're within Supabase, I'll show you what the table looks like in my database here. So if I just go ahead within my project and I show you the table, so you see I have message history, just like I had shown you in the backend there and front end. Now here's all the different responses. Now, if I go ahead and edit table, the way that I set this up is I set it up with a payload of JSON. Now, once you have this more set up and closer to production, I'd encourage you not to use JSON and actually leverage the database as it's more intended. And you could put in you could put in type, you could put in content, and put those in separate keys. I found this nice just to use JSON because it gives you the flexibility without having to constantly touch Supabase in initial development of a project, and you're able to just send over whatever payloads so long as it's within the JSON format. But once it's, like I mentioned, closer to production, encourage you to actually use columns for all the different fields here. So you could use a column for type, you could use one for content, etc. Now, the other thing that you'll see that I have here is I have it enabled for real time. You'll have to make sure to turn that on for that real-time functionality to work. And then I also have turned off, just for demonstration's sake, the RLS, or the row level security. You could tighten this up again if you're wanting to do something like this within production. But in this example, I'm running something locally and just running through the steps here, I just turned this off for demonstration's sake. So that's pretty much it. If you found this video useful, please like, comment, share, and subscribe. Consider a subscription on YouTube or on Patreon. And otherwise, if you found this useful, I'll look forward to seeing you in the next one, hopefully. Take care.